Welcome viewers. I shall tell you today about the acidic character of phenol, or you may say why phenol is acid. Let me tell you, this is phenol. In the market, this compound is known as carbolic acid. So, regarding its acidic character, out of the three theories of acid-base concept, the first one is Arrhenius theory of acid and base. The second one is Bronsted-Lowry theory, and the third one is Lewis concept. I shall explain the acidic character of phenol with the help of Bronsted-Lowry theory, which says acid is that substance which can give up, which can donate H plus ion, which can donate H plus ion. Now, when this phenol will give up H plus ion, it will form phenoxide ion. If this reaction is possible, or if phenol will give H plus, then we shall say that phenol is acid. Now, why this phenol will give a proton? We have to explain phenol is unstable and phenoxide ion is stable. We have to explain. If phenoxide ion is stable, then all compounds will try to be in a state of stability, and that is possible when phenol will give rise to a proton, a hydrogen ion. Now, for explaining the instability of phenol, we have to show that phenol is not stable and phenoxide ion is stable. Then only H plus ion will be liberated. Now, this will be explained with the help of its resonating structures. If a compound will have more resonating structures, then it is more stable. If a compound will have less number of resonating structures, then it is less stable. Another point is that if there is charge separation, then it is not stable, it is unstable, and if there is no charge separation, then it is stable. So, with the help of the resonating structures of phenol and phenoxide ion, I shall explain you that phenol is unstable and phenoxide is stable, so that it will always try to give rise to H plus ion. Let me tell you. Now, let me write the different resonating structures. How many resonating structures are possible for phenol? This oxygen has atomic number 8. It has 6 electrons in its outermost orbit. One is donated to here hydrogen for forming this bond. One is donated to this carbon atom for forming a bond. Now, how many electrons will be left behind? There will be 2 pair of electrons. Because out of the 6 electrons, one is given here and one is given here. Now, 2 more pairs are left behind. Now, this compound, 1 pair of electron will move to this side, then this will go to this side. So it will be 1 electron will go, it will be positive plus, this will be double bond, this will be minus, this will remain as usual. Now the next structure will be, this electron will come to this side, it will come to this place. So we have plus, this will be double bond, this will be minus here. Then the next structure will be this electron will go to this side, here it will come to this side. So it will be plus, this will be here, it will be double bond here, and here it will be minus. Then the last structure is, this will go to this side and it will come to this side, plus will be neutralized. So the final structure is like this, here, it will double bond, this is OH. We have started from phenol. It will be one resonating structure, this will be another, this will be another. There are 3 resonating structures, or if you say this is one structure, this is 2, this is 3, this is 4, this is 5. Either you will count there are 3 resonating structures or there are 5 resonating structures. I have drawn all the figures here in the board. So total number of resonating structures is 3 or 5. If actually these 3 are the 3 resonating structures. But from the beginning, if you count and it will end up with the initial structure, then the total will be 5 structures. Now let me tell you, for phenoxide ion, this is the first structure. It will come to this side and here it will be. double bond O. This is double bond. Then the next structure is this structure will come to this side. This is double bond O. Here that will be double bond. Here it will be minus. This is there. Then the last structure is it will be polarized. Now, if you count the regenerative structures, this is 1, this is 2, this is 3. Or total structures are 1, 2, 3, 4, 5. So I want to argue in this way. For a phenol, there are either, you will say, 3 regenerative structures or in total 5 regenerative structures. The same number you will find in case of a phenoxide ion. It has also the same number of regenerative structures like that of a phenol. So, how to argue that phenoxide ion is stable than phenol? The same number of regenerative structures we have found here. But in the first case, there is charge separation. Here you will find positive charge and negative charge in all these cases, positive charge and negative charge. But here, the same negative charge throughout. So, in the case of phenol, there is charge separation. In case of phenoxide ion, there is no charge separation. Hence, phenoxide ion is more stable than phenol. A compound will always try to move from a state of instability to a state of stability. That is possible only when phenol will give rise to a proton. Phenol has the same number of regenerative structures like that of phenoxide ion. In case of phenol, there is charge separation, whereas in case of phenoxide ion, there is no charge separation. Hence, phenol will try to move from a state of stability it will move from a state of instability to a state of stability. This is not stable, this is less stable. This is more stable. So it will try, phenol will always try to move to the state of phenoxide ion, and that is possible when only when one H plus ion will be given. Hence, phenol is acid. Because according to Bronsted-Lowry theory, a substance which can donate, which can give off a H plus ion, that will be called as acid. I hope it's clear to you all. There is no problem, I hope. Okay, thank you all.